Hello, everybody. So today we're going to be looking at 1.4 right equations and inequalities. Before we get into this first slide, though, I'm going to have you guys try out some warm-up questions dealing with what we were learning in the last lesson. If you guys remember, in the last lesson, it was all about like order of operations and plugging numbers into expressions. I want to have you try that here. So go ahead and take a minute, copy down these directions, get these two problems, try them out on your own, and then we'll see how it goes. So take a minute, try this out. Okay, so now that you've had a chance to try these, let's just kind of recall what we were learning yesterday. So evaluate the expression when x equals 7. So basically it's just telling us plug in 7 for x, do the math. Okay, so let's try it out number 1 here. So on number 1, we have a 4x minus 12. So I'm going to rewrite this, and instead of x, I'm going to plug in 7 for x. So 4 times 7 minus 12. Okay, just a little, order of operations reminder. PEMDAS, let me just put up in parentheses, exponents, multiplication, division, and addition, subtraction. PEMDAS. If you guys remember, multiplication and division are interchangeable, so are addition and subtraction. Whichever one comes first is what you'll do first. All right, on this one, looks like we have multiplication, subtraction, so of course we'll do the multiplication first. Okay, 4 times 7, 28. All right, now finally we can get to subtraction. Really simple math, it's fundamental order of operations here. So it looks like 28 minus 12, it looks like we're going to be getting 16 here. Okay, so on this other problem, kind of the same idea. We're plugging in our 7 for x. So I'm going to rewrite this. 5 times 7 minus 4. Sorry, that kind of looks like a 2. All right, order of operations. First thing we got to worry about is parentheses. We have some. Okay, looking inside, it looks like we only have one operation, but just remember when you go into the parentheses, you kind of restart your order of operations. You look for more parentheses and then exponents, multiplication, division, and so on. We only have subtraction, so we'll do it. So 7 minus 4 looks like we're getting a 3. So we're getting a 5 times 3 and 15. Okay, so nice, simple warm up there. So let's get into what we're doing today. So today we're still kind of dealing, I guess we didn't really deal with equations a lot in the last one, but yeah, we're getting into equations and inequalities and kind of reminding you of what some of these words mean. The first few examples are going to be us looking at word problems, really simple word problems, and then we'll actually just get into some like normal inequalities. All right, so here, let me just scroll down. By the way, don't forget to get the title at the top of your notes. You should be doing all of these notes with me on a separate sheet of paper. Everything you see should go on your notes unless I say otherwise. Okay, so that should be on the top here. And here's our first slide here. Okay, go ahead and take a minute and copy this down. Okay, and you can see we just have these different symbols, their meanings, and then the associated words, kind of how they'll be represented when they're written in like a long, drawn-out format. Okay, so the first symbol everyone's familiar with, good old equal sign, okay, meaning equal to. All right, if this was written out in a sort of a word problem, you might see the words the same as. If they're saying something is the same as something else, they're saying they're equal to one another. All right. So from here, we get into our inequalities. All right. We have our less than or equal to, greater than or equal to. All right. It's easy to get these signs mixed up, and I would highly recommend, if you haven't started memorizing these, to do just that. So when you see something like this, you don't have to guess, does that mean, is that a less than sign? Is that a greater than sign? All right. Some people, you guys know, like the old school trick, like the mouth, like you think of this as like eating this. If we have a number here and a number here, this is saying that x is less than y, because the mouth wants to eat y, it wants to eat the bigger thing. So if you want to think of it that way, that works. Okay, but kind of the big thing on this slide is, what are the associated words? If I see, if I'm supposed to use a less than symbol in a word problem, okay, here's some ways it'll be represented. Okay, fewer than. Okay, they're saying something is fewer than another thing. less than, that makes sense. Okay, less than or equal to, we'll see at most or no more than. Okay, when we get to our greater than, we'll usually just see that written as more than. Okay, simple enough. Okay, greater than or equal to, at least, no less than. Okay, and really those two, I think the less than or equal to, greater than or equal to, when it comes to the associated words, those are kind of the weird ones. So we might need to flip back and just kind of remind ourselves when we see these word problems. Okay, so let's go ahead and try one out. So we're going to do an example here. Go ahead and write out the directions, and we will try this one together. Okay, so basically this is giving us the equation as, a sentence, and they want us to convert it into equation form. All right. So, don't be overwhelmed. It's best to, maybe read all the way through it, but then take it one piece at a time. So this is saying the difference of twice a number k and 8 is 12. Okay. So first things first, the difference. All right. Difference. When we are talking about what symbols represent difference, that would be subtraction. What's the difference between, this amount and that amount? We're subtracting those numbers. All right, so I know I'm using a subtraction symbol. I'm going to go ahead and write it. Okay, so what am I subtracting? Well, I'm finding the difference between twice a number k. Twice a number k. So if I have a number k, and they're saying twice the number k, that means 2 times k, 2k. Okay, so twice the number k, the difference between that and 8 is 12. Okay, is another way of representing the word equals, right? So the difference between those two things equals 12. Okay, and really this thing just told us to write the equation. It didn't say write the equation and then solve the equation, but let's solve it anyway. It's really, really simple. I just want to remind you of like a few, I guess, principles when it comes to solving. All right, so when we go to solve for a variable, there is our variable, k. Our goal is to get k by itself and get everything that isn't k to the other side of the equal sign. Okay, well, we got two things we got to worry about. We have a 2 that's being multiplied and an 8 that's being subtracted. All right, which one do we deal with first? Okay, if you guys remember, we always deal with addition or subtraction first when solving. You can almost think of it as like the reverse of the order of operations. We're dealing with addition and subtraction first, and then multiplication, division, and we're kind of working our way. That's one way of thinking about it. So always deal with addition or subtraction. This 8 is being subtracted. I want to get rid of it, so I'm going to do the opposite operation. I'm going to add 8. And remember, whatever you do to one side of an equation, you have to do to the other to keep things balanced. Okay. So these 8s cancel out. I like to cross them. We're left with the 2k on the left and on the right. We can add these together, 20. Now we can get rid of the 2. The 2 is being multiplied by k. Remember, technically, there's a little multiplication dot between these, but normally we don't write that. They're being multiplied. To undo multiplication, we do the opposite operation, divide both sides. Okay, these cancel. We're left with k. And over on the right, 20 divided by 2, easy enough, 10. Okay, next example. So again, go ahead, copy this down, and we'll try it together. Okay, so this is saying the product of 4 and a number w is at most 51. Okay, first things first, dealing with this word, the product. Okay, when we're finding the product of two things, we are multiplying them together. All right, so when it says the product, we know first things first, we're dealing with multiplication. Okay, what are we multiplying? It says the product of 4 and a number w, which is just the variable w, is at most 51. Is at most. That's really the big thing in this question. What do they mean by is at most? How do we represent that mathematically? Okay, well, if it helps, flip back to the beginning. Okay, is at most, we're dealing with, it looks like, yeah, our less than or equal to symbol. Okay, all right, which kind of makes sense, less than or equal to is at most, right? So that is what we're going to write in here. So less than or equal to and 51. Okay, so there is our inequality. If we wanted to simplify this, normally if we write 4 times w, we write that as like a 4w. Okay, this might be like the cleaner way of representing it. I would take either or, but this looks a little nicer here, right? It didn't ask us to solve it again, by the way, but just so you know, if we wanted to, looks like 4 is being multiplied by w. Okay, so to get w by itself, we would get rid of 4 by doing the opposite, dividing. Okay, but we'll leave it here. We'll just write the inequality. All right, so I'm gonna have you guys go ahead and try this one on your own. Okay, practice problem. Go ahead, copy it down, try it out, and then we'll look over it together. Go ahead. Okay, so this is saying the product, okay, of 6 and the number n is at least 24. So it looks like product, we're dealing with multiplication again, right? And what are we multiplying? It's saying 6 and the number n, and it's saying is at least 24. Is at least. Hopefully when you did this on your own, you looked back up in your notes and you were looking at the different, ways to represent these words. And let's see, scrolling down real quick. Okay. Sorry, let me see, I'm blanking here. Is at least, sorry, I had at most in my brain. Yeah, so is at least, well, looks like we're dealing with the greater than or equal to. Okay, so that is hopefully the symbol you're able to put into your inequality here. Greater than or equal to, let me make it black. Okay, 24. And there we have it. There is our inequality. Okay, and again, if we wanted to write it a little bit more kind of nicer looking, 6n greater than or equal to 24. Okay, didn't ask us to solve it. We won't. We'll just leave it as is. Okay, let's keep moving. All right, next example is asking us to check whether x equals 3 is a solution. All right, so this is a lot like our warm-up. They're having us plug a number in for a variable, but this time we're plugging it into an actual equation and not just an expression. All right, so we'll plug them in and we'll see if it actually works. Okay, go ahead, take a second, copy down this slide, and we'll try this one together. Okay, so let's go ahead and plug in 3 for x. Let's do this top one here. By the way, let's call this letter A just to kind of break them up a little bit. Okay, so letter A. I've got an 8 minus 2 times x. Again, we're going to plug in 3 for x equals 2. And that's really the question. I put a question mark here because that is the question. Does it actually equal 2? So I'm going to keep that question mark there for now until we actually do the math. Right? So let's see what happens. We know that first thing we need to do over here is our multiplication. Negative 2 times 3 is negative 6. So we're getting an 8 minus 6. All right, and you can see where this is going. The question is does that equal 2? Put the question mark again. Going one more step, it looks like yes, 2 equals 2. Okay, and what that means is, yeah, 3 is a solution. All right, what I sometimes like to do is put like a check mark next to it, like, yeah, it worked. Okay, or we can say, yes, it's a solution. Okay, whatever you'd like. Okay, let's try this other one. So again, still plugging in 3 for x. So let's go ahead and do it. 4 times 3 minus 5 equals 6. And again, that's the question. Does it equal 6? We'll keep that question mark there. Okay, order of operations. Let's multiply first before we subtract. So 12 minus 5. Does that equal 6? All right, and go ahead and do your subtraction here. Does 12 minus 5 actually equal 6? Nope, doesn't look like it. Looks like we're getting 7 equals 6. Let's see, I forgot my question mark here. Okay, so is 3 a solution for this equation? It looks like no, it's not. Sometimes I put like a big X here, or again, you can just put no, don't work. Okay, so really simple, but now we're just kind of dealing with the idea of plugging numbers into an equation, seeing if it actually works. Okay, so let's have you guys try. Actually, let's try another example together. Okay, let's do it in the context of inequalities now. Okay, so again, we're going to plug in 3, basically the same directions. So you don't necessarily need to rewrite these directions. Let's just go ahead and copy these 2 inequalities, and then we'll try it together. Okay, so let's plug in 3 for the variables here. So I've got 2 times z, which again, we're plugging in 3 here, plus 5. Okay, and we got that symbol, 12. Okay, and I'm going to keep the question mark. Okay, here's the thing. I said that symbol kind of vaguely, because what if you didn't know what this symbol meant? Okay, what if you didn't know the difference between a greater than or a less than symbol? It'd be kind of hard to get this problem right 100% of the time, right? Okay, so we got to remember this is a greater than symbol. All right, so let's see what happens. 2 times 3, we're getting a 6 plus 5. Okay, so the question is 6 plus 5 greater than 12? Well, we know 6 plus 5 is 11. And is 11 greater than 12? No, it is not. Okay, so again, if you want to put a big old X there, or no, that works. Okay, maybe no. If you don't have different colors, maybe no makes sense because in X, sometimes we use that as a variable. So no, I kind of like that a little better. Okay, let's try this next one. Again, plugging in 3. So we got 5 plus 3 times plugging in 3 for n. This symbol, 20. All right, pretty easy math, but if we don't know what this symbol is, it's going to make it harder than it needs to be. And you guys remember that's a less than or equal to sign. Start memorizing it if you haven't. Okay, starting with our multiplication, we got 5 plus 9. Is that less than or equal to 20? Well, we know 5 plus 9 is 14. Sorry, forget my question marks. Is 14 less than or equal to 20? Yes, it is less than or equal to 20. So this one works. Check mark, yes, whatever you'd like. Okay, cool. I'm going to have you guys go ahead and try one of these. Okay, so your practice problem, we're going to check whether 10 is a solution here. Okay, so get those directions because they're new. We got a new number in there. Go ahead and copy these 2 problems, plug it in, and see if it actually works. Okay, try it out. Okay, so really simple math, right? So let's try it on the first one. Plugging in 10 for our variable, we're getting 10 plus 5. Okay, we got this symbol here and 15, which by the way, I forgot the question marks on this one, but let's still put question marks because we're still wondering, is it a solution? Does it actually work? Does it make sense? Okay, easy math. Looks like we're getting 5. We have this symbol, or 15, and we have the symbol and 15. And that's the question. What is the symbol? Well, hopefully you're starting to remember less than. So here's the question. Is 15 less than 15? No, it is not. 15 is not less than 15. So 10 is not a solution to this inequality. Okay, here's a fun little bonus question. What if, instead of just a less than sign, what if this was a less than or equal to sign? Would our answer still be no? No, right? It would be yes, okay, because 15 is less than or equal to 15. All right, so be careful. Those symbols, they matter. All right, taking a look at this other one, which again, if you wanted to call this, letter A, letter B, sorry, I forgot that. Plugging in 10 here, so we got 2 times 10 plus 3, and we're wondering, is that greater than 21? All right, simple math, let's do it all together. 20, or 2 times 10 is 20, plus 3, we're getting 23. Is 23 greater than 21? Well, obviously, yes, it is. But if you didn't know this was a greater than symbol, and you accidentally thought it was less than, you might get this wrong, right? So that's really what this lesson is all about, remembering what these symbols mean. Okay, so this does work. Let's go ahead and say, yes, it is a solution to the inequality. Alrighty, so that's kind of it for today, guys. I hope this is kind of a good refresher on inequalities and just remembering what all these little symbols mean. So I'll see you guys back in class. Have a good one.